You can see the topic we have already noted down is trigonometric identities. So I'll be taking up trigonometric identities here in this discussion. Let me just draw a figure, then take up the first basic three of them and then explain how that has been derived as well. I name them. Let me just write, this is line Y, this is X, this is denoted as PM, it's A, that is theta. The first one it says is sine square theta plus cos square theta is 1. Now how is this arrived at or derived at, you can say? Sine theta in this figure is perpendicular by hypotenuse, that giving me PM by AP. On the other hand, cos theta is base by hypotenuse, that is AM by AP. Now it says square of sine theta, that means what? It is PM by AP whole square plus AM by AP whole square. Or if I write it separately, the LHS part, it will be PM square by AP square plus AM square by AP square. Now I take the example LCM. LCM will be AP square, and then I'm left with PM square plus AM square. Now if you see PM square is this and AM square is this, this being a right triangle, we can apply the Pythagoras theorem. So the sum of these two square of these two sides will be equal to the hypotenuse, that's giving me another AP square by AP square, that's 1. So we prove that sine square theta plus cos square theta is equal to 1. Now let us move on with taking up the second identity, which says I can just move on to the second page and draw another figure to show the same thing. I'll just draw a smaller one. Sorry, this is P and this is M. I had drawn this is A and this was theta. The second one it says is sec square theta is equal to 1 plus tan square theta. Sorry. Okay, or I can simply write 1 plus tan square theta is equal to sec square theta. You can take from any of the sides, start doing it. I would write what? 1 plus what is tan here? The tan here will be perpendicular by base square. So it is 1 plus PM square by AM square. So we'll be getting AM square plus PM square by AM square. Again, AM square plus PM square is again giving us AP square by AM square. Or rather than moving on to this, I have to prove it to be 1 plus tan theta. So I just separately write it How do I get this as, oh, I got it as AP square. Oh, I missed it, sorry. AP square by AM square is what? AP is hypotenuse, AM is base, so it is hypotenuse by base, which is actually the opposite of the cos, that gives it sec. They were all in square, so it is sec square theta. The third one which is given in the same, I would try fitting that here. The third equation is cosec square theta is 1 plus cot square theta. Now here again we do that. What applies here? It applies that AM square, sorry, plus AP square, no, plus AM square plus PM square is equal to AP square, that is as per the Pythagoras theorem. Now if the whole of it is divided by MP square, what do I get? I divide the whole equation by MP square, both of them. So it will be AM square plus PM square by MP square, and this will be AP square by MP square. AM square plus PM square by, yeah. Now I'll just separately write it, taking it off from the common denominator. I also have this AP square by MP square. Now AM square by MP square is actually can be written as AM by PM whole square, right? I can write this as AM by PM whole square. These two are kind of getting cancelled. This is equal to 1, and also this can be written as AP by MP square. Now this is AM by PM, that is base by perpendiculars. It is opposite of tan, which is cot square theta plus 1. This is AP is this hypotenuse and MP is the perpendicular. It is just the opposite of the sine. This is equal to cosec square theta. This is the third identity. So the first one we learned was cos square theta plus sine square theta is 1. The second one is sec square theta is equal to 1 plus tan square theta. And the third one is cot square theta plus 1 is equal to cosec square theta. Now based on these three identities, we take up a couple of questions how these are applied in the questions based on trigonometric identities. I have moved on with a blank screen. Let me take up a question. This question says about proving certain trigonometric identities. Let me take up a very easy one, not that easy one, kind of the basic application of such identities. The first question, I write it as practicing trigonometric identities question is very important, because only remembering the basic identities won't help. At the particular question, how is that applied is the trick where it lies. Now it says you have to prove cot square theta minus 1 by sine square theta is 1. I continue with the left hand side first. So simple is this, because 1 by sine square is actually cos square, is cos. 1 by sine is cos, so 1 by sine square will be cosec square. What does the the third identity say? It's a 1 plus cot square theta is equal to cosec square theta. It says 1 plus cot square theta is equal to cosec square theta. That means cosec square theta minus cos square theta, if you carry this to the right, gives you 1. So here we get it 1. So that was we were supposed to prove. This is a kind of a very simple application. Now let me give you a couple of questions for you to practice maybe by yourself. Try it out. I can give a simple one. I tell you how to go for it though. This is supposed to be proved as cosec theta plus cot theta. This is a question for you. Now, you first take up the left hand side that says sine theta by 1 minus cos theta. Now, this kind of question, I just give you a kind of first step because I think this is very much new to you though. Multiply the numerator, because you need to remove 1 minus cos theta in the denominator and reach somewhere which has cosec. Try to multiply, or not try, do it, 1 plus cos theta by 1 plus cos theta. Multiplying the numerator and denominator both by 1 plus cos theta, 1 plus cos theta. Now you can proceed. Just multiply and keep this sine theta and 1 plus cos theta, and here you are getting 1 square minus cos square theta in the denominator. So 1 minus cos square theta is sine square theta. So what ultimately you get is 1 sine into 1 plus cos theta by 1 minus cos square theta is equal to sine square theta. Now this sine theta and one of the sine theta will get cancelled. So it gives you 1 plus cos theta by sine theta. Now give separately the denominators to both the terms in the numerator. So that give you 1 by sine theta plus cos theta by sine theta, and you get the right side. I've just given you the kind of how you go for this question and an independent practice as well. I give you, let me just take any question which I think will fit in. The method will remain same. I suggest that multiply the numerator and denominator. For the first session I'm giving you simple questions. Yeah, okay, this one I can find is tan theta minus cot theta equals to 2 sine square theta minus 1 by 2 sine theta cos theta. I can give you a kind of a hint that break up this tan and cot on the left as per sine and cos, and then continue with LCMs and all. That will make you reach this. I guess you'll get to do this because the next part we will be taking up different kind of application of the same three identities. I hope you get that. Thank you.